mail. This is like the 5th time I'm trying to make this video. And last time I got like halfway through it, and my kid calls me. In the middle of the day. In school. Kill him. Let's try this again. It's story time. Incidentally, on my phone, when I'm recording and somebody calls, their recording instantly quits. And if my phone decides to be a dipshit about it, then it saves it as a broken file, and any future video I make is a broken file until I restart the whole damn phone. Hanging directly in the middle of my ass. But anyway, so there was a debate on evolution and intelligent design. The judge shut that down. He was convinced that evolution is a settled matter because he doesn't know shit about it. And I don't say that because I'm Christian. I say that because I've listened to a lot of material on it. And the math does not add up for a very specific part of evolution, which is random mutation. It's not there. And it can't be there. Because, now I listened to Michael Behe most recently. Behe, Bravo, Echo, Hotel, Echo. Say it how you want to say it. I'm saying Behe. So I listened to him, and he made some outlandish claims. But once I went online, found some college lectures on DNA and genealogy and gene splicing and how all this stuff works, and one of them on cellular mutation, not so outlandish anymore. His math works a hell of a lot better than, say, for instance, Lynch's math. Lynch is one of his detractors. When I found out that Lynch did an experiment to prove him wrong, I checked out that experiment. Not bad as far as it goes, and the experiment itself proved that he could come up with the math to explain evolution in the time frame that we have. Not quite. See, let me explain this. And I'm going to make this math so easy that even my unicorn understands it. Maybe. I think. I might be able to. I don't know. I think that's pushing. Anyway. So, in case you slept through biology class, which I did not, so I've got the terminology for you. First, there's DNA. Everybody's seen DNA. You've seen the double helix. That sounds smart, didn't it? You got the double helix, and then you got the lines and the dots. And even if you slept through biology, which I didn't, you've played Resident Evil, and you've seen what DNA is, except that's zombie DNA, so probably a little bit different, but not that you would really notice. So DNA is a collection of genes. What these genes do is they really tell. Anyway, we're breaking this Barney style. They tell the cells how to make proteins and how to use the proteins and regulate them to do their job. Cells have jobs. And they don't get paid for it. It's a rough deal. So these proteins are what's in the cells, like hemoglobin in red blood cells. Hemoglobin is a protein. It is what pulls in the oxygen from your lungs, and then transports it around your bloodstream in your red blood cells to allow your blood cells to do their damn job. I just said that. So these proteins are made of amino acids. Now, there are 20 commonly used amino acids. There's actually 22, but those 2 amino acids are in-laws that are only invited on special occasions like Hanukkah and typically any other day ending in Y. Those 2 amino acids aren't welcome to the party. We just got the 20. So we're only going to go with the 20. And that makes the math easier on the side of evolution. Not that it really matters. But, so the deal is, you get amino acids lined up in formation, specific formation, with specific amino acids in each formation, or in each placement. Just like you can't have private, specialist, sergeant, private, corporal, private. It don't work like that. You've got to have a specific line. Only in proteins, amino acids are more like G, C, G, TH, and then underneath that is a separate little chain of G and C, and it branches out, and then it stops, and then the original chain keeps going, and then it has another tree above it, and it's complicated as all shit. But everything has to be perfectly lined in there, for the most part, for the protein to function. Now, you can get an amino acid or two that are screwed up, and it will still perform its function, albeit more limited, unless it mutates or breaks. But one amino acid difference is considered a mutation. That is how most mutations happen, is one amino acid is off. Take, for instance, in your brain, you got brain cells, and you've got TAC1 protein in some brain cells, and that TAC1 protein is what tells your body when you've got an owie. It works with pain receptors in your brain and nerve endings, and it tells you when to say ouch. It has other functions too with the immune system and smooth muscle usage, but let's just go with the pain. And everybody understands pain. We got this. So, this TAC1 protein, 129 amino acids in its string. Obviously it recycled a couple, but, and the protein doesn't necessarily use all 20 amino acids. It can mix and match however it wants to. But if it mix and matches wrong, it's no longer a TAC1 protein. Now, 129 amino acids might seem a little excessive for ouch. Maybe we can just take 5 amino acids and pitch them out the window, and we'd still at least have an ow. No, that's not how it works. If you take 5 amino acids and you just change all the C's to G's, well, 5 of them anyway, then you won't have an ouch gene anymore. You might have, instead of feeling ouch, you might feel it, ooh. Shut up, I know where you're going at. That would be a problem, wouldn't it? Wouldn't be a TAC1 anymore. It would be probably hilarious, but it would be wrong and shit would change. So you cannot change up amino acids like that. Random mutation says that each time there's a replication of a cell, there's a possibility that the functional portion of its gene will be slightly altered, so that it will alter an amino acid in a functional protein. A chance. Now, here's the thing. He was going on about HIV and malaria, and on and on, and geez, on. It took some fortitude to get through that, I'll tell you what. But the gist of it is I withstood that so I could pass knowledge on to you. So, HIV is obviously the most studied virus in history. And they've had studies on HIV from the time someone was tested and found out they had it, taking blood on on a relatively constant basis, like weekly, to see if that HIV has mutated and see how it's mutating all through people's lifetime. They've studied the piss out of HIV, and they've seen just about every possible mutation of HIV. That said, there's only 2 types of HIV. There's not really a mutation. HIV has a 15 gene sequence DNA. Very, very, very small DNA cluster. So, since at any given time, if you have HIV, you have about 1 billion of these virus cells in your body, and they replicate constantly, you have, over the course of a lifetime with HIV, those HIV cells have experienced every possible mutation by changing every single amino acid and mutating to damn near, or if not, every single other possible amino acid. And we've seen no new protein sequences. We've seen no major mutation. Seen adaptation, kinda. HIV is extremely resilient, drug resistant. The scientific explanation of that is there are so many HIV virus cells in the body, and they mutate so quickly and reproduce so quickly that if you develop a drug to change 2 amino acids in the protein or the outer cellular structure of that HIV, there's going to be at least a few cells that have mutated themselves already, and that drug's ineffective. That'll work. You might kill off most of the HIV, but you've got some HIV that's mutated to resist that drug. And it won't be much. You might recover a little bit, but those are going to keep replicating and continue to screw up their amino acids and mutate. And originally you got the original form of HIV because that's the preferred function. Now, this is how it works. And they're studying malaria and HIV and E. coli in Michigan. This dude studied E. coli for like 40 years. Ridiculous. But he's got some data on E. coli and the evolution, or lack thereof, of E. coli mutations. We have not seen any major mutations. It does not result in complete loss of function or death of the subject. Meaning, like E. coli. His E. coli experiment, at some point, the E. coli was able to digest citrus in an oxygenated environment. Not supposed to happen with E. coli, but he had a mutant strain that adapted to do that. Fortunately, by changing his genealogy, change his DNA to allow it to do that, it screwed it up, broke it, and they died. It is what it is. That's how evolution works. That's how the sickle cell works. Sickle cell was the African answer to malaria. Long ass time ago, somebody's hemoglobin developed into sickle cell, and they fought off malaria. Malaria doesn't kill them. They were able to pass on their genetic makeup to their kids, and then to their kids, and to their kids, and now we've got all kinds of people with sickle cell. But while sickle cell fights off malaria, hundreds of thousands of years, malaria mutating has not found a way around sickle cell. It has not been able to develop a new protein to bind in a different manner, or to get around sickle cell. It's still dying from sickle cell. It can get around drugs, but it can't find a way around sickle cell. Downside of that is that when the body mutated to sickle cell, now anybody that has sickle cell not only dies younger, but they have unexplained pain, and you don't die from malaria. Congratulations. But boy, ain't you gonna have a time of it anyway. That is how evolution works. Their mutations work. It's a hell of a lot easier to break shit than it is to make new shit. Now, well, we've had hundreds of millions of years, so what's the problem? Well, that actually is the problem. Because once you start throwing hundreds of millions of years in the equation, then we've got like 4.5 billion years since the formation of the Earth. And that's, what is that, 1.6 trillion days? Congratulations. You can have a population of 1 trillion mutating every single day, and you never have even a slight hope of developing the TAC1 algae. Because, and here's my math unicorn, I'm going to break this down Barney style, 20 different amino acids, 129 amino acids to make up the TAC1. If we give nature the benefit of the doubt and assume that it took another 129 amino acid protein to make the TAC1, make it as easy as possible now. It's only got to change one amino acid to get the TAC1. The problem is, through random mutation, there is no direction. So you have to account for trying every amino acid in every position. Like the first position, if it's a C, you got to try G, then TH. You've got to try every one of those 20 amino acids in the first position, move on to the second. The formula is, to do that, your chances are 1 in 20 to the 129th power. I know. Let me explain. That's unfathomable. So, let's go to an easy one then. Well, easier. Astrophysicists decided they wanted to figure out how many atoms are in the universe. I don't know why. But they did. So, they looked at our sun and said, that's pretty average for a star. Looked at our solar system and said, that's pretty average for a solar system. So, let's count the stars in the universe, not the galaxy, but our galaxy, Epsilon, Texas, every damn galaxy they can see. And they came up with 10 to the 84th power of atoms. And atoms, millions of them in a grain of sand, atoms? Atoms. That's how many atoms are in our universe, allegedly. It's not exact, obviously, somewhere around there. Now, that is a 1 with 84 zeros behind it. That's what 10 to the 84th is. The importance to that, and why that matters, is that our universe is 10 to the 84th atoms. If you smudge that and make that 85th, that doesn't add 10 atoms. That adds 10 universes. That adds a 0 onto the end of it, which makes it, instead of 1 universe, 10 universes. Throw another 0, 100 universes. Every single number you increase on that power takes it up exponentially. You're throwing it up by a factor of 10 every single time. Except in our analogy, where it's 20 to the 129th, if it's 20 to the 130th, you're multiplying it by 20, and getting 20 more, 20 more times the possibility. That's what's unfathomable about all this. Is it's numbers that are incomprehensible, but the universe gives you something that you can actually, you can feel. You can consider, there's a lot of shit out there. So 10 to the 84th is a lot of shit, right? It gives you something you can relate to. And 10 to the 85th is 10 universes. You can understand that every single number on that power means a hell of a lot. And yet, we're talking about 20 to the 129th. Just for one protein. Now, granted, it's not going to have to try every single option. I'll grant you that. But if we average it, then we still got, cut that in half, we still got 20 to the 64th, 65th. Yes. That's still massive. And if you take 1 trillion, just one species, take 1 trillion cats. Obviously, there are not a trillion cats, but we're trying to be as generous as we plausibly can. Take 1 trillion cats, have them have baby cats every day. Yeah, it's ridiculous. All right, so we're not being plausibly generous. We're being ridiculously generous. 1 trillion cats having a baby every day. Every day, every baby has a slight mutation in one protein in their brain. Okay? No duplicates now. Every single baby has a different mutation. Then the math on that, 1.6 trillion days since the formation of the Earth. That's 1.6 times 10 to the 12th. 1 trillion kitty cats every day is 10 to the 12th. So if you give 1 trillion cats a baby every day that's unique, special little Timmy with 1 amino acid different, that's not like anybody else's amino acid ever. 1 trillion over 1.6 trillion days is 1.6 times 10 to the 24th. 10 to the 24th.
A new message has arrived.
And then you multiply that times 1.5 or 1.6. That's hardly much difference compared to the 10 to the 24th. 10 with 24 zeros behind it. That's how many times a mutation can happen. Because, yeah, I'm replicating cells on a constant basis. And yeah, a lot of them are probably mutated. But you don't see evolution in the current generation. The next generation inherits the genes that are mutated, about 30. And scientists estimate that when a baby is born, when a mommy and a daddy have a baby, that baby has 30 proteins that are a little bit different from mommy and daddy's. 30 amino acid mutations. A lot of your DNA is copies, and a lot of it is broken. A lot of that we share with primates. That's how science has proven that common ancestry is a thing, and has proven that we did evolve from primates. Sorry if you're Christian, but that's just how it is. If you believe the Bible, you should know better by now. We've already proven God didn't make the animals and then the next day make man. That's just fact. I'm Christian, but I accept reality. And I can alter my beliefs based on that reality. You're going to have to do the same. Because we be monkey babies. That's how it is. Nothing you can do about it. It's been proven. And it's been proven by the same molecular DNA that proves that random mutation is not a thing. Because the math does not add up. There have not been enough living organisms since the dawn of time on Earth for them to have a plausible chance of creating one new unique protein that is complex. Because the TAC1 didn't even know that's special. 129 amino acids, that's on the low side. There's freaking proteins with hundreds of amino acids. I'm not even trying to be all that difficult about it. I'm giving evolution the benefit of the doubt. But science has gotten to the point where, no kidding, the oldest bacteria they found is like 3.2 billion years old. Billion with a B. Billion years old. Old as hell. Like the Earth was 1.3 billion years old before this bacteria was sitting there. So they found bacteria that was 3.2 billion years old. Oldest known organism. Now, if they keep digging, get down to about 4 billion years, and they find 2 stone tablets, same size, right next to each other. Perfect Hebrew, 10 Commandments written on them. That will elicit a scientific response, yeah? And it will say, science has proof of earliest bacteria that eats stone. Fascinating designs in stonework from early bacteria. A week later, 10 Commandments theory debunked. That's science at this point, and that's no shit. They get down to the genes and the DNA and the protein sequencing and see exactly how perfect it is and how inalterable it is for us, even though we understand it, and they still say, yeah, it's an accident. And then the math says it can't be an accident, and yeah, it's still an accident, as long as you don't talk about God or intelligent design at all. I mean, I understand. I hate that guy with the part on the frickin' side of his head, wearing the black frickin' suit, with the Bible over his heart, talking about, do you have a moment to talk about our frickin' Lord and Savior Jesus Christ? Everybody hates that guy. But science is talking about, he's knocking. Let's fucking burn the house down. No! Go tell him you're an atheist. That's what normal people do. When we talk about intelligent design, we're not talking about, all right, now we need to save some time for our Lord and Savior Jesus Christ. No. I'm not saying the only solution to evolution is, oh my God, so Noah did create the animals on the ark. I knew it. No. I'm saying there has to be a medium. Somewhere in between. Yeah. Sorry, Noah creating animals that's a disturbing image. I should not have said that. That's going to give me nightmares. So, there has to be some happy medium between our Lord and Savior with that jackass standing on the porch and burning the house down because you don't want to talk to him. There's middle ground here somewhere. Let's find it and get over to the acceptable intelligent design where the math does work. And because, I mean, like right now, okay, here's evolution. In the Precambrian era, there were jellyfish that weren't really jellyfish, and there were mollusks that didn't have shells, so they weren't really mollusks. And there were sponges and these fucked up worms with segments. Okay, and then the Cambrian explosion saw real mollusks with shells, and real worms and real jellyfish. It's not really jellyfish, it kinda. And then you've got a couple 100 million years, or 100 million years past, and you've got this catfish. And this catfish sees the USS Ronald Reagan with big teeth and says, that shark's too big. So he goes somewhere else and lays eggs and has babies with legs so they can get the hell out of Dodge. And they walk up on the ground and they see all the ground, lots and lots of ground, and there's a lot of oxygen. So they get bigger and they get bigger teeth, and they poop a lot from whatever the hell they're eating to make trees, and they grow up to be T-Rexes that eat the others, that grow up to be brontosauruses that eat the trees that their poop made. And then a couple 100 million more years, an asteroid falls and it freaking covers the atmosphere in dirt, so there's not enough oxygen, and the big lizards can't breathe because there's not enough oxygen for those Volkswagen-sized lungs, and there's no sunlight anyway, so lizards aren't doing that well, so screw them. But nature says, how about we give them a fantastic dew and throw some hair on them, and it'll be good. And it was. They lived, and they got warm blood and breathed less, and a couple 100 million years later, I'm talking shit on my phone. The only thing science says is a problem and all that, besides my wonderful, not a lot of Axl Rose fans in the science community, but aside from my hair, the only problem they have with that is nature said everything else is fine. It's just nature said. Nature can't be smart. You cannot make nature logical at all. Put a freaking fish running away from a shark and making a T-Rex that died and made a freaking saber tooth that turned into a chimp. Perfectly reasonable. All accidental. Can't have nature saying shit. Come on, guys. Come on. Accept what the math gives you and quit with the burning the house down. Instead, talk about the Lord and Savior Jesus Christ. There's got to be something in the middle.